Okay, so one thing of having these base exponential graphs and having a basic understanding of them is we can create an infinite number of other graphs using transformations. And so what I'm going to do in this case right here, where I want to sketch the graph of f of x equals -5 times 4 to the x plus 2, is I'm going to look at a base function of this type. Importantly, again, this is a times b to the x. And just so you know, what I'm going to consider is I'm going to look at the function f of x equals 5 times 4 to the x. So I'm going to identify some details about this and then apply the transformations that I see up here. And by the way, this transformation right here, this negative on the outside, this is a vertical flip when we think about it graphically. But algebraically or numerically, that represents multiplying y values by -1. And this right here is a vertical shift up 2 units. So again, this is a little bit different than our previous techniques with transformation because we had these toolkit functions that we started from. Here, the exponentials, we're going to think of these as, well, actually we have an infinite number of toolkits of this type. And again, I've identified this with the starting value of 5 and then this exponential growth factor of 4. And what I'm going to do is identify the 2 points that I know. And this is what I was previously talking about when liking 2 points, is the fact that if I have these 2 points, I generally understand what's happening here. I then can get a really quick sketch from just using these 2 points. And it's a hell of a lot easier than using 1 point. If I had just 1 point, I'd have to do all the analysis of, is this growth or decay? Is it increasing or decreasing, especially after these transformations? But what I'm going to start with, and now looking at this function right here, I know I have a y-intercept of 0, 5. Again, that's 0 and then just this a value. And then I also have the point of 1, 20, and 20 always comes from multiplying those 2 values together. And then what I'm going to do is I'm going to then just take these 2 points right here and run them through these transformations. I apply my vertical flip first before I do my shifting. So what I'm going to do is I'm going to apply the vertical flip, which means I'm going to multiply the outputs or y's by -1. And so what that will give me in this case, when I apply that transformation, are new points of 0, -5, and then 1, -20. And so again, that represents just this flip over the y-axis. Then I'm going to apply this vertical shift right here to these points. So this is a vertical shift up 2, which means I'm going to add 2 to the y's. So what I'll get from that, in this case, this is now 0, -3, is adding 2 to -5, and this becomes 1, -18. So I have my 2 points. I've ran them through the transformations that I see of this function. The only other thing that I need to be aware of is this horizontal asymptote. So after this flipping and this shifting, where does the function tend to and when? And so importantly in this case, we had a horizontal asymptote at y equals 0. This is a growth function. Now I'm thinking of this function right here, right? So it's at 0. It's an exponential growth function. So as x goes to -infinity, I actually approach that horizontal asymptote. I'll keep that feature unless I do some kind of horizontal flip. The good news, I don't have a horizontal flip, I just have this vertical shift. But in this case right here, when I vertically shift this graph up 2 units, this horizontal asymptote also gets shifting. So this move right here also affects this horizontal asymptote. So I now have a horizontal asymptote at y equals 2. And again, all I've done there is as I've added 2 to the y's, I'm also adding 2 to the y value, which represents this horizontal asymptote right here. All right, we've done all the hard work. All we need to do is sketch our graph. And you'll see, given these 2 points I have right here and this horizontal asymptote, it's actually incredibly easy to graph these if I can do this work. So we're basing this f of x function that we have right here of -5 times 4 to the x plus 2 on this toolkit exponential function 5 times 4 to the x. Now, importantly, 5 times 4 to the x is this exponential function that would rise like this, going through 0, 5, and then 120. So actually it'd be more like that right there. But what we've done is vertically flipped that and then shifted it up 2 units to get this function right here. But I don't need to think of any of that jazz. What I can just do is stick to these points. So I have 0, -3. So 0, -3 would be right about there. I have 1, -18, which would be right about there. So this function now is going like this. All I need to do now to get a pretty dang close, nice sketch of my graph is apply this horizontal asymptote at y equals 2. So I don't have an asymptote at 0. What I have is this right here at y equals 2. I have this horizontal asymptote. And that takes care of it. There's only one option for what this graph can look like. And now we know, I'll say we need to know this is a function, and it also has that exponential shape that we're looking at. There might be a little bit of ambiguity here, like after the transformation, am I tending toward the horizontal asymptote this way or that way? Knowing that it only obeys that horizontal asymptote from one of those directions. But that's the beauty to me of having these 2 points. First of all, I know I need to connect these 2 points, which then directly means if I connect these points, I sure as heck can't approach this horizontal asymptote from this way, because that would require one of 2 things. Either I do this and then do some weird bending back, which is not an exponential nature, the graphical nature of an exponential function, or I can maybe connect here and then swoop around, but I can't fall back over itself or it wouldn't be a function. So the only option is for me to connect these 2 points right here. And this is where that kind of exploding exponential nature is. And then from here to the horizontal asymptote, I'm then reaching that horizontal asymptote right there. And again, these are the points at 1, -18. And this is the point right here at 0, -3. Always a final good check is to think about the nature of this, like we discussed before. That would be a function that looks like that. When we vertically flip it, it sure as heck would look like something like this. And then we shifted it up 2, we just had this end behavior idea with the horizontal asymptote, shifted up to y equals 2.